everyone, welcome back to Manufacturing Hub. I'm very excited to go continue this industrial AI theme. I know Vlad's very excited to go continue this industrial AI theme. We'll introduce Virag in just a moment, and I don't know. The conversations we've been having ahead of this make me very excited for the conversation that everyone gets to go be a part of. So if you guys are new here, welcome. If you've been here before, welcome back. If you're new here or you've been here before, maybe you followed Virag and Twin Thread in. Manufacturing Hub, every Wednesday, Vlad and I go and we talk to different people in the industrial manufacturing sector about a different theme. This month, we're talking all about industrial AI. This is, in fact, our 5th episode. And so if you guys are catching this as the first one, go back and listen to the others. They are all absolutely 100% fantastic. And I am happy we were able to go ahead and put this together. But without further ado, everyone officially welcome to Manufacturing Hub. This is episode 256. My name is Dave Griffith. This guy up here is Vlad Romanov. We'd like to thank MaintainX for sponsoring this theme. We'd like to welcome our guest aboard, Virag. Virag, thank you so much for being here. Welcome.
Yeah, thank you
Virag,
guys for having me, Vlad and Dave.
absolutely. Thank you for joining us for the conversation today. Before we dive into the actual conversation on AI, could you give us an introduction of your background, please? How did you get into the industrial space and ultimately what you are doing today?
Sure. Yeah, I mean, we met a month ago in person, and it was great being at a conference where a lot of folks have a background that I can resonate with. So, very similar to a lot of my colleagues at Twin Thread and where I've worked in the past. I studied chemical engineering in college, and I started, I entered the workforce just a few years before COVID. So obviously a very different time. It's hard to even remember what that felt like. I'm sure for you guys, it changed a lot of things as well. But
Mhm.
my initial role was more focused on the deployment of MES and DCS for an Emerson impact partner. So we worked a lot on recipe authoring, on DCS design, deployment of Delta V, Syncade, and that was primarily for the biotech industry. So after that,
Interesting.
I kind of saw a lot of the difficulties with, or the challenges rather, associated with enabling your everyday engineer to develop applications on their own for work instructions, for data collection, for kind of rudimentary or generally common tasks. And that kind of brought me to Tulip, which is where I was before Twin Thread. And so you guys may have heard of that platform. I'm sure you guys have, but for the
Mhm.
for the audience or listeners, it's really intended to democratize app building. And app building can range from, like I said, digital work instructions to data collection to OE, machine monitoring, so on and so forth. And that journey pushed me further into the realm of what can be made accessible to domain experts, to
Mhm.
process engineers, reliability engineers, without them having to relearn an entire skill set like software engineering or data science. And that's what brought me to Twin Thread. So at Twin Thread, my role is really focused on showcasing what the platform is capable of for potential clients, and then helping design solutions that combine their existing data stack with what Twin Thread offers on top of it. And I know we'll
Mhm.
get into the platform in a moment, but I kind of like to think that each stage of my career they've built on top of each other, as I'm sure is true for you guys and other folks
Mhm.
listening. But what's really been uh, what I'm really grateful for is the opportunities have lined up at these inflection moments where I've been able to continue down a very specific strain.
Mhm.
So yeah.
Let me ask you a follow-up question on the background side, right? So I'm curious. You've mentioned that you studied chemical engineering and then went into this more, I would say, like software and sort of SCADA MES application development
Mhm.
route. Was that intentional? Is that something that you sought out? I still talk to students in universities in
Mhm.
fields outside of like software, electrical engineering, computer engineering, who are asking again, like, are there opportunities in our space? So I'd like to maybe for you to share a bit more how that decision came to be.
Yeah, I mean, I chose my father's an engineer as well. He's a mechanical engineer. He's worked for a precision golf ball manufacturer for over 30 years. He actually just retired, and I know we'll talk about one of the projects I'm doing later because of that. But that was kind of the inspiration from a very young age for me. Chemical engineering specifically drew me in because of the expansive applicability. I know even before I entered university, I knew chemical engineers who had gone to work in more of the traditional energy industries, biotech. Growing up in the Northeast, biotech and pharma has always been a home for a lot of very talented chemical engineers. And then as I was kind of entering university, I saw a lot of folks head into the control space, automation, and then kind of start overlapping with functionality that typically was reserved for software engineers. So the possibilities of that discipline was really, I would say, a deciding factor in me pursuing it. And heading out of university, I did want to be close to that manufacturing hub for biotech and pharma in the Northeast. So that's kind of what brought me into that first job that I had.
Interesting. I can tell you, like, really briefly on my side, my university did not have a like manufacturing or industrial type of a program, so I had no knowledge of the opportunities in the manufacturing space coming out of the program. But I got very fortunate in some of my early careers again to have gotten the education that I needed on the
Mm-hmm.
workforce to be able to fill those gaps. So but like I said, I still talk to engineers that don't understand how many different opportunities there are for
Right.
different disciplines in manufacturing. So it's great to hear your
Yeah.
story as well.
Like very
Um,
much like you're saying, it's really the mindset, the problem solving methodology. Like that is
mhm.
what you're learning, and then a lot, like probably the most valuable education that I had, as well as you, like what you're describing, is when you're actually doing the job itself, and that's going to compound over and over.
Mhm. Let me ask you, I guess, another follow up question, right? So I picked up on the fact that you also mentioned starting out maybe with lower on the ISA 95 stack systems, like DCS, SCADA, to then transitioning into more of, MES, MOM, and sort of like application based development. How was that also maybe like transition like? Did you really enjoy or was the experience initially beneficial to spend more time on the plant floors to understand some of those challenges to then make that transition? Could you elaborate on that a little bit, please?
Yeah, for sure. I think, I mean, looking back, yeah, I think all of that was necessary at the time. Showing up Christmas week for equipment validation maybe wasn't my favorite thing, but
Hmm.
having gone through it, and seeing what it takes for signals to actually process. Right now, I work with a customer and I'll see a tag come through on its win, and there's a state tag, and actually being able to understand what went into somebody touching that piece of equipment, configuring it. I mean, I'm not going to claim I've never actually, written any PLC logic. I've been around it, but kind of understanding the source of that, I think that makes what I do today even more valuable.
Mhm.
That's going to be harder and harder for everybody to have access to. I recognize those opportunities aren't always going to be, something everyone can jump into, but at least grounding yourself in the world that the customers that you work with, the clients that you work with, are living on a day-to-day basis is extremely valuable. So
Mhm.
like what I was describing earlier, that the fortunate nature of my career progression, I think exactly what you're describing also includes being able to see data on different levels as it's collected, as it's associated with process data, as it's associated with human augmented data. Like all of that, it helps me understand the full picture quicker. I would say
Mhm.
today, I can look at a process, I can look at a use case, and use all of that historical context I have to get my hands around the problem a lot quicker than I would otherwise.
Awesome. And let me ask you one last question before I pass it over to Dave. You've mentioned, COVID was obviously a big change or inflection point during that timeline. I would argue that AI is probably going to be a lot bigger than that from a technical standpoint. So I'm curious, in a broader sense, right? Since we're talking about industrial AI, could you explain like where do you see uh, some of the biggest impacts of AI, but also we're going to get into some definitions. I would like to better understand. You've already mentioned digital twin. What kind of maybe impact is AI having on digital twin as well?
Yeah, I think at its broadest, or in the broadest stroke, it's enrichment of whatever that definition is. All the concepts that we we still use very heavily in industry today, some that we'll talk about in terms of golden batch, digital twin, even SBC, um, advanced process control at the edge, like all of these concepts, they get supercharged with the addition of AI, and or with the layering of AI. And I would argue, they're closer to what their initial form was supposed to be, if that makes sense. Like the promise of a lot of these concepts is only fully realized when you layer, um, at the very basic level, machine learning to be able to actually correlate a lot more parameters a lot more quickly than you would otherwise. When you layer semantic search, when you layer LLMs that can sort through a lot more data than any human can. So the concepts, I think, are still foundational and solid and sound, but when you when you start to supplement them with technology that sends that concept leaps and bounds over what it has been in the past, it almost reinvents the original concept. Like we'll tell people today,
Mhm.
we're centered on digital twin. It's like, wait, I've heard that in the past, and it's a concept that feels antiquated, but what it is today is a lot more powerful than perhaps what it has been able to be in the past.
Makes sense. Thank you.
Absolutely. I like how you said that, Virag, how it almost kind of reinvents or fulfills the promise of what something should be. Talking about centerlining or perfect batch or digital twin, and we'll get into a lot of those. But I'm also thinking back at a number of different projects that I've done in the past, and Vlad and I have talked about. I'm like, in the past, if I needed to go pull something out of a manual, I was control find and I was
Yeah.
manually searching for it, and then I was highlighting it and I was copying and pasting it, and then I was
Right.
also linking it back to the page in the manual, and hopefully other people were doing that. And you can only do that so many times in a day or so many times over the course of a project, and you can only hopefully get the top 80% of the problems that they're going to have. But with LLMs, with lots of the additional compute that we now have, I don't have to do that. And I think I've told Vlad has heard me say multiple times with a big smile on my face, nothing makes me happier than not having to sit in a bad hotel room doing that for 10 hours on a Monday that was a holiday. And my clients aren't working, but the project still needed to get done. So I'm here on a Monday that is a holiday in a bad hotel room, going down the process of doing this. So I love that. I am very hopeful with the future, especially of these applications, that it continues down the path of continuing to fulfill that promise, and end users really seeing the value and continuing to invest in that. You
Yeah.
mentioned digital twin. As Vlad and I have said, we've had several conversations about digital twin. Digital twin is one of those words that mean different things for different people. And I know the work that you're doing on the twin thread side and some of the stuff that we've seen it prove it, and some of the things that we're going to talk about is kind of based upon the concept of a digital twin. So can you go build us that foundational digital twin framework, please?
Yeah, in the realm of the twin thread platform and how we structure data and what we're doing with that data, a digital twin is kind of it's entirely data centric. So it's a data driven representation of a process or an asset, and it's the real time data and the historical data that's feeding that interpretation. So this isn't necessarily going to be the same definition that you will have if you're approaching like a augmented maintenance use case where you want to
Mhm.
have like a 3D CAD CAM model that you can have a virtual engineer kind of scan through and guide somebody. That's I would argue is probably still a digital twin, but the way we
Yeah.
describe it is entirely data centric. And um, the reason that's important for any type of AI that you want to deploy on top of it, it's kind of the home on which you contextualize your data, on which you define critical events, alerts,
Mhm.
things that you'll want to be enriching to ultimately create data sets to train models for various objective focused use cases later. So the term that we use, digital twin, and I
Yep.
think it's fair to assume that a lot of
Mhm.
different platforms, depending on a manufacturing environment, depending on the technology stack that you're using, you probably have asset models that if you throw a little bit
Yep.
more on, we would probably see the same thing. You would say, okay, yeah, that's a
Mhm.
digital twin. Just how we define these objects in the platform as an organizational tool.
Absolutely. I like that. I feel like that's a very clear definition. I am personally interested to see the direction we go as an industry, and if we continue to define like the prerequisites as a digital twin, if we go define it as something else, I feel like it's still very new
Mhm.
as to knowing we need this data and knowing we need this information, but how we go ahead and define and describe that, I am interested to see where we go as an industry. But talking about digital twin, we'll continue it down the digital twin path. So, what do the prerequisites look like? So, you need to go build a digital twin to deploy some of these AI different style of solutions. Do we need data? Is there like an MES, a manufacturing execution system, that is required? Is it just sensors? What does that look like in order to go down the path of deploying a digital twin for you?
Yeah, I mean, what we've seen, like we work as a company in Twin Thread, we
Mhm.
work a lot with process industries, food
Yep.
and beverage, chemicals, um, you know, uh, uh, a lot of process types that are CPG as well. It's like
Mhm.
hybrid. So sometimes they're fully batch oriented, sometimes they're semi-continuous packaging lines, fully continuous. So these each of these settings from the industry itself will require a somewhat different massaged interpretation of what that twin
Yep.
looks like.
Okay.
So, for example, if you have a fully automated batch process, which a lot of our customers have automated batching systems, so those batching systems already have a definition for a batch train, the units within those trains, and then what operations, what phases run on each of those units. So when we
Mhm.
convert that into our realm and we want to, use as much of the standardized object definition as possible, we're just converting those one to one. The batch train is a twin, each unit is a twin, and then if you have
Okay.
any subunits defined in your recipe, those also become twins. Whereas some customers that we work with, they have data, they have historians, or maybe they even have an OPC enabled PLC, but they haven't really done anything with it. And they say, hey, we have all this telemetry data, but we don't really organize it anywhere. What should we do? Right. And that turns
Okay.
into, okay, start with wherever your most valuable context exists. So if that's at a line level, if you want to map all of your telemetry data to an extruding line because you don't have any definition further down on individual assets, that's fine. Right? Use that as a starting point. As you continue iterating on your use cases, you'll get further into what children of those parent twins look like. At its core, you need some data though, and I think depending on what your use cases are, depending on the type of process you run, the volume of available data will look slightly different. But really, the types of industries and processes that we're focused on at Twin Thread are generating lots of data, lots of telemetry data, tons and mounds of time series data, some contextual data to understand, when different recipes or products are running, what those key events are to segment the
Mhm.
time series data. And that's really about it, because everything beyond that, we often find that you can derive from the telemetry data. If you want to say, compare performance in colder months versus warmer months, we can extract what those seasonality differences are from ambient temperature and humidity sensors. You don't need to pull that from an MES or pull that from a different system. You can just define that in the realm of whatever use case you're trying to define.
Let me ask you maybe a follow up on that side, right? So, from a more practical standpoint, because I've gotten this question personally coming from customers, right? In the manufacturing and industrial automation space, the challenge that I often find is that, again, systems, depending on how they're labeled and what kind of functional specs you have on hand, may be easier or more difficult to tie together, right? So,
Hmm.
taking a simple example, right? You have some kind of a tank that's going to cook your batch, you have a temperature sensor. How do you tie in a practical sense, let's say, that temperature reading to that specific batch? Is that you that goes in and makes that connection? Is that something you can query an LLM to help you with? Like, how do you establish that sort of software relationship to the physical world?
Yeah, that's a good question, and that's kind of like what I was trying to explain in terms of the event context, the envelope
Hmm.
of interest, if you, whatever you want to call it. Like a lot of times, depending on the tool that you're using, if you're doing the kind of manual forensics, you would open up a tool and kind of and map the start time and end time of batch and say, okay, what was the property behavior during this?
Hmm.
What we're doing with the digital twin definition is trying to make that more programmatic. So you say a batch starts when this rule set happens. Batch ends when this rule set happens. So now go back in time and figure out however many batches occurred in the month of March and April, compare them to each
Oh,
other and analyze what that
interesting.
telemetry data shows across those batches. And now compare against batch size or compare against seasonality. Like those are common examples that we see because anecdotally, you know, me and my team of engineers know that as the weather heats up, our feedstock that isn't necessarily stored in a temperature controlled environment starts to develop a little bit more condensation or starts to get a little looser. And when we bring that into our process and we mix it and we heat it, we tend to get a product that's a little bit less viscous than we want. And we know that we kind of have to play on the edge of the boundary of what our limits are, but now you have a model that tells you, yes, you're accurate, and yes, we can help you understand why that is the case and when to act on that intuition. So it's all about trying to make all of those context windows as yeah, programmatically developed as possible.
Interesting. I hadn't picked up on the fact that you can apply some of those, I guess, like windows or definitions retroactively, right? I'm assuming it depends on what the end user has
Available.
available as far as
Yeah.
data. But that's super interesting, right? Because I think there was like a few different train of thoughts, and Dave and I have had this discussion over the years as well as to should you just collect all the data and store it on a server because again storage is relatively inexpensive considering how
Yeah.
much like downtime is going to cost you with the intent there's going to be better solutions that can analyze like more specific or more granular data versus is some of it a waste, right? And that's where certain groups go into the cloud and obviously make a point of we're paying all this capital, we don't have a use case yet. But this is a very interesting point that you're making where again you can retroactively go back and retag or reclassify or whatever the process looks
Yeah.
like some of the historical data. That's super interesting. Um, Let me ask you, I guess, a follow up, right? So I'm curious. Again, you've mentioned a couple of use cases, but I'm also starting to think of where this could be applied. Is it to solve ongoing issues? Is it looking back at batches and understanding why they have failed so we can prevent some of the further occurrences? Is it, you know, perhaps synthesizing some data on how a completely different product or batch would run within the system? Is it all of the above? Like, could you explain maybe where does the digital twin, as you describe, shines the most?
Hmm. Yeah, at its core, it's really in environments, processes that have an inherent source of variability. This technology does very well. And the reason I kind of frame it that way, like if you have a a process that's entirely governed by first principle models, and you know that you're achieving all of the theoretical yields, theoretical mass balances. You're able to kind of calculate that out, and your process actually adheres to those theoretical calculations that you're doing. You can just simulate all day, and you can be, very, very satisfied and accurate in your results. You have no need for machine learning or anything beyond the scope of what you can build out by writing down a bunch of equations, even in an Excel spreadsheet, and say, yes, I know what will happen. But the reality of the industries that we serve is that that's not going to be the case. Everything from raw material variability, atmospheric changes, shift to shift variation, there's going to be a multitude of different reasons for process variation. And so if we hone in on the batch use case, we have some customers who are interested in more of that retroactive use case that you mentioned, Vlad, which is, hey, we want to understand, we have a final QC check that we do, and sometimes this is below our tolerance, our pHs are out of acceptable range, and we don't pick up on this during the batch, so we want to understand, kind of do a fingerprint analysis of what a good batch looks like, what a bad batch looks like, and then hopefully isolate where that variability is occurring, and focus more training on there, or kind of dedicate more time to researching what's happening there, look for process improvements. Other customers are a little bit more proactive, and this is where we'd like to see more focus in terms of the use of the technology that's available. Use these models to inform real-time decision making, right? And that can range from simply, hey, there's a batch in progress. The current phase is about 14% longer than it typically is, and some of the process variables are starting to leave the envelope of safety. So there's a medium anomaly, trigger an email alert, trigger some sort of notification to Slack or Teams, so somebody has to go and take a look at what's happening in more detail. Also list out what are the top drivers for this anomaly. So is it the temperature that's looking off? Is it the combination of a couple different properties that are looking off? And use that to hopefully catch an ongoing batch issue before it becomes irreparable. That's kind of the perfect use of what we would define our perfect batch model. We recognize, and we have to get there gradually with most of our customers. Nobody's ready for that on day one, and nobody should necessarily go into using technology with an assumption that it's going to automatically be controlling and dispatching, dispositioning my batches. But it is possible, right? And that's like, whether it's Twin Thread or another platform, another set of tools that you're using, you always want to be focusing on, how does the insight actually turn into something that somebody can do? Not just, hey, raise my hand, there's an issue, or and on light turns on. What can somebody do about it?
I like that. Talking about applications that some people named Dave have devoted hundreds or tens of thousands of hours of their life into going and trying to showcase kind of those upper and lower limits within an SPC funnel. As temperature goes up and down, I feel like that is a fantastic example of something that has so many variables, and in the past is so difficult in order to go build that tunnel or that funnel within SPC with all of those upper and lower limits and all of those raw material and process variables, because you had to be able to contextualize and call out every single one of them and know exactly which sensor to look at during which point, or which timers are running for each of the subsets of processes. Being able to go on your side and go collect that raw data and retroactively go ahead and look and compare how one batch looks from batch to batch, and then hopefully get better is very appealing. I can certainly understand why there's more thought and demand. Virag, you had mentioned a really interesting point, right? And so you had talked like temperature changes, and well, some of us are still solidly in winter, some of us are starting to become into spring. And to your point, everyone knows temperatures change and manufacturing facilities run differently, no matter how climate controlled they are inside or how unclimate controlled they are inside. Raw materials that sit out and bake in the sun, or raw materials that live in uninsulated, non-air conditioned areas, are going to behave differently when they're 80 degrees Fahrenheit than when they come in and they're freezing at 20 degrees Fahrenheit over the course of the winter. how is that presented? I guess like walk us through the path. How is that presented? If Vlad is the client, do you say, hey Vlad, I've noticed these things? Is it on the client side to say, hey, as temperatures change, I'm noticing this, and you guys are on the opposite side saying, hey, let us go through and do some remodeling? How do those conversations typically happen?
Yeah, I mean, for the most part, it's generally an area of focus, like whether
Mhm.
it's the main causal factor for material variability or like a subsequent one, it's somewhat dependent. Like oftentimes it's more of where the raw material is coming from. So if that's the
Mhm.
primary segmentation argument, we'll go with that first. I guess I should back up. All this translates into is when you're training a model on, hey, help me find my ideal center lines for this recipe, or help me find the ideal, profile for batch conditions for this phase in this recipe. All what we're talking about influences in that model training is how you're segmenting your data, which is, I got 2 years worth of historical data. Do I want to create a body of samples that have to do with summer, winter, spring? Or do I want to create a body
Mhm.
of samples that have to do with raw material ABC? Or do I want both of those to be bodies of samples that I'm analyzing against?
Yeah.
So that means that when the model is training, it's referencing each of those condition sets in the samples that it's scraping for the features of all the
Mhm.
data that's being analyzed. And then when it's executing, so when it's running and actually giving you some guidance, it's going to look for what segments the current conditions fit into. So what is the most relevant segment for right now, for the current batch, for the current run? What profile does it fit into? Um,
Mhm.
so yeah, seasonality is a common segmentation type or profile type that we see used, especially in situations where both the raw material quality is influenced by seasonality and the storage conditions are influenced by seasonality. Like we had a use case last year with an orange juice manufacturer who, they basically, when you think about any sort of crop, it's
Mhm.
entirely impacted by the
Yeah.
climate changes and the yield across season. So, determining whether or not that orange juice should be sold as fresh or whether to send it through to concentrate because there's not enough
Mhm.
natural sugar in it and they should just add sugar and freeze it. Like that's
Yeah.
all based off of that variability.
Absolutely. I've done orange juice. I've seen those raw oranges literally sitting outside being baked by the sun, held up literally by 2x4s that were originally put up in like the 1950s. And as long as they're not falling down, no one is touching those 2x4s. So that is much more advanced than the side of orange juice that I've had the opportunity
Yeah, that's
to
wild.
work on. Yeah, absolutely. Vlad, what are your thoughts?
Well, I was smiling a little bit as Rag was explaining some of the applications because I'm looking back at some of my experience and I've done projects where there was quite a bit of uncertainty in terms of the actual outcome, right? And I can
Mhm.
explain in high level details, but quite a few projects revolve around getting more throughput on a production line.
Hmm.
And a lot of those initiatives would be to, let's say, increase the speed of the line by, let's call it 20%, but also to understand, because as you mentioned, between different shifts, maybe the operators sometimes change the speed of the line. And there could be arguments to be made. Maybe we should lock up the speed and that shouldn't be available. But when it is an opportunity, it's a very difficult question to answer as to what will happen at a different run rate, right? So, from the electrical standpoint, as long as the software has been written accordingly, you can have, electrical gearing, you can have basically a speed up that is seamless from the software standpoint. And again, barring, sensors are maybe reading too slow and whatnot. But ultimately, from the mechanical standpoint, and I was surprised to hear this in my first project, they quite frankly don't know what's going to
Right.
happen, right? They have a general idea like, well, the motors shouldn't fail, the gearboxes shouldn't fail, but we will have to see basically and point one of those like heat guns to understand, is it overheating, is there going to be a problem? So for me, like I said, it would have been really interesting to see if you could have applied that model to see, instead of jumping by 20%, maybe let's go up by 5% and see what can we learn, what kind of data can we capture. Because again, it's possible that the line is running faster, but there's more quality defects,
Yeah,
there's more
exactly.
stops on the line, right? So you know what I mean, there's so many variables. Quite frankly, at the time, and this was, you know, over 5 years ago, we were just looking at shift data manually, right, and trying to understand, well, this is the
Compare, yeah.
percentage of like rejects we have, this is the number of stops. But again, I think the human brain is not as good at correlating all of those variables and parsing multiple, you know, like runs into kind of this is better, this is not
Hmm.
necessarily better. So again, I'm thinking of some of my current projects where this might be very interesting, right? Because you can go to the customer and say, we can help you get there,
Hmm.
if we collect enough and obviously the right type of data. So again, like I'm maybe like curious to hear some maybe thoughts not only on the process side. Maybe this was a bit more of a discrete application. I'm curious if there's use cases similar along those lines, or anything else you're able to share where this was really beneficial.
Yeah, I think high speed discrete tends to be where we focus because at that rate, you tend to mimic more of a like the signals that are coming off of your process tend to
Hmm.
mimic a bit more of the continuous profile that a lot of the algorithms that we use that we use in the platform rather are tuned to be able to analyze well. The challenge with like manual assembly or maybe even like automotive at times, you know, we have some use cases that stick well, like on the paint side for being able to analyze like paint quality attributes and associated defects once they're sprayed. But in general, these models are only going to be good as the volume of data that our process is providing it. So,
Hmm.
you know, we've had some use cases that have gone, I would say, moderately well, like not as shining as they are on a fully continuous process, mainly because there aren't as many levers to pull in process,
Hmm.
at least in the use cases that we've seen, like on a packaging line. You set up all your machines at the beginning of a run. You set up your labeler, your cartoner, and you have different configurations. You have, you know, depending on the artwork, depending on the carton size,
Hmm.
you set everything up with that, and then as you run, during that run there are in some indicators of defect rate. Let's say like one carton size or one particular type of artwork will likely have a higher defect rate for some reason, and then you can get back and do that comparison run to run. But like I said before, you know, the retroactive analysis is a component of what we want our customers to be doing, but the real value add is what can I do right now in real time to affect this particular process to reduce that
Hmm.
defect rate. And oftentimes in that high speed discrete world, there isn't much. The answer is stop the line, reconfigure a couple things, try again. Versus on the continuous side, there are things that you might be able to tweak, you know, some small adjustments that you might be able to make. So I'm not sure if that's like a similar process
Hmm.
type to what you're describing, Vlad. Maybe if there are more tunables or controllables that can go a little more smoothly, but that's kind of what we've seen.
Yeah, and look, it's giving me some thoughts on both sides, right? Like the reality is I talk to groups in different, I would say, like industries, and a lot of even process facilities do end up with some sort of a packaging environment towards the end
Right.
of that process. So I think all of it is relevant, but again, I'm trying to better understand where this might be more applicable. And I guess as a follow up question, you know, what are the general prerequisites, right? So you've mentioned obviously you can pull data.
Hmm.
Again, when I start talking about data, and depending on whom you talk to, and I'm curious to hear your experience, of course, there's I would say, like varying degree of data. Again, some systems will collect it once every 5 minutes, which is fine for, you know, basic OE metrics, and
Hmm.
you can get some case counts and maybe an array of faults, for example, that happened. But ultimately, for process or even high speed packaging, that is inadequate to solve some of the more, I would say, like shorter type of problems. So I'm curious, when you have conversations with potential customers, what are some of the early prerequisites, maybe on the setup, on the data side? Do you often go in and plug into an existing like control system, historian, MES? And again, what are some of the guardrails? Because again, I'm sure you hear
Mhm.
this all the time where they don't have as much data as is probably needed, but of course they would want to get the right answers. And where do they need to get to start seeing an ROI?
Yeah, it comes up all the time. A lot of the enterprise customers that we work with will have either an on-prem historian, or they've kind of gone down the route of corporate data lake, so we can tap into that, and
Mhm.
that's fine. But the crux of what we're trying to do, and the reason we have over 60, 70 different connectors for data sources, we expect and almost embrace the fact that most manufacturing sites are stitching together amalgamation of different data acquisition systems that have been deployed over the decades, right? And that
Mhm.
shouldn't stop you, but just because it's not all in one place, or just because it's not all contextualized, that should not be the barrier to being able to deploy our industrial AI. In fact, even if you have time series data that you're storing at a very uh, low frequency, 5 minutes, you can train a model, and that model will say, hey, this is what we're able to find. But if you have a little higher resolution of your data, this is what we could tell you. And once you have that
Mhm.
insight, like once you have the, hey, this is possible if we deploy better instrumentation or beef up some of our on-prem collection, that becomes an easier sell than, hey, I need, couple $100,000 for capital investment for instrumentation. I don't know what I'm using it for, but once you have that end in mind of, I already have a model that's doing this much with the data I've collected kind of accidentally. What happens if I'm intentional about collecting data? These models
Mhm.
become so much more accurate, so much more robust, and reliable for that closed feedback loop. Ultimately, if you would want to do that.
Gotcha. Could you let me ask one last question before I pass it to Dave? Because you mentioned something around, like, does can the model also tell you what's the accuracy of the assessment and then recommend per se, like, hey, we should get more granular data on these specific points, as opposed to just like blanket, let's do it on everything, right? It will
Yeah.
suggest what is needed. Interesting.
Yeah, as it's doing its training, it's the model pipeline, the model factory that we've developed in the platform. It almost mimics what a data science team would be doing at large organizations, right?
Hmm.
They're collecting data sets, they're first filtering, applying brushes of different features, and then doing feature specific analysis, and then data set as a whole analysis. So part of that is what we call a data manifest, which you can interact with. It's an artifact that's generated in the platform, or you can use we call it twin thread advisor. It's kind of the LLM that's layered on top of the functionality. It's really intended more of like a tool to help you interact with the artifacts for model configuration, for data interrogation, all these types of use cases that we're talking about here. But part of
Hmm.
that assessment is precisely what you're talking about. Out of the 200 model topics you included, 20% of them are exhibiting uncharacteristic flat lines, or in the 6 month historical data that you provided to train the model, there were 80 or 100 different sample periods that look like they were outliers because they didn't exhibit anything that is typical for a running state. Can you double check on those? For these particular features, they change every single 5 minute interval. So if you can increase the resolution, all of that analysis is part of the training workflow that a model goes through.
Interesting.
That is
But the
really
goal is to
interesting.
not
Yeah.
make that something that, like, if I'm a process engineer, I can't really spend my time thinking about everything that's going to recommend to me. So try to automate it as much as possible so that it'll drop features or it'll drop properties that don't make sense right now. It'll tell you that dropping them, but hey, don't worry about it for now. Let's move forward and see what we can do with this model.
Okay. That's really interesting. I want to keep going down, especially on the model and different flavors of AI side. But first, we've got some people to thank. We want to thank MaintainX for sponsoring this show and the entire theme and the continued support for Manufacturing Hub.
Here's the painful truth. Your technicians are spending 40% of their time looking for answers, answering radio calls, and not focusing on what really matters, fixing assets. That's why we built MaintainX. Now your technicians can leverage AI to get the answers that they need instantly, focusing on what really matters, getting the asset back online. Check out MaintainX.
Thank you again, MaintainX, for sponsoring this theme, and thank you, Colin, for such a great ad read. This entire theme and me not having to do it. He definitely did a better job than I did. If you guys want to learn more about MaintainX, go check out Nick. We had Nick Haas, co-founder, on a couple of episodes ago, so go check out episode 254, where we had Nick on most recently talking about AI. Speaking of AI, if you guys want to learn more about AI, specifically deterministic AI, which I imagine we'll get into in just a minute, in all of the show notes and in all of the chat links, go ahead and check out a webinar that Virag is going to be on, the Twin Thread LSI 4-hour webinar, which is going to be April 14th, which is this coming Tuesday at 11 a.m. East Coast time. So you guys go ahead and please feel free to register and check out that. I will not be on it. I will certainly be in attendance, and I'm very excited to continue to go learn more. Virag, talking about different types of AI, we've mentioned several different types, right? We've mentioned machine learning. We mentioned LLMs. There's agentic AI. There's deterministic AI. I guess walk us through the different flavors of AI. Walk us through how you're using them, or walk us through how different people are using them in the industrial space in your eyes.
Mm-hmm. Yeah, I'll preface this by saying I'm by no means classically trained in any of these fields, but it's kind of what Vlad was saying through using technologies, through deploying them, everything that I've learned kind of helps me calibrate, and then I use other resources to double check those assumptions as well. But yeah, I mean, I think at its core, what we're at Twin Thread, what we center around is machine learning, and it's in a lot of ways it's not as new, flashy, or attractive as what we would refer to as like agentic AI or LLMs are today, because here's a chat I could do and automatically presents me results, and I am going to assume those results are true. The foundation of the solutions that we deploy, centerline, batch, quality, like those objective focused solutions that are deployed in the Twin Thread platform are looking for characteristics of data sets that help form a representative match of a model to a process. And you can do that with a lot of different tools. You can build that on your own, right? Basically using different algorithms, using different, whether it's in Python or R, and kind of trying to understand which dynamics fit to a process or the way an asset behaves. But by incorporating that into the broader platform that we offer, which is that twin context, that event contextualization, and then deploying these algorithms in an effort to solve specific objectives, that pipeline of infinite possibilities becomes much more streamlined. And I can do that without necessarily being a data scientist. I feel like the layering of agentic workflows and LLMs on top of a good foundation of machine learning is much more powerful than letting those other flavors of AI loose on raw data. And as you mentioned kindly, the webinar that we're doing next week, the LSI team along with 4AR, we're kind of unpacking a lot of what we built, both specifically for our Prove It conference demo, but also what went through our minds as we were going through the path from, hey, how do we analyze process data and get to a point where people can trust the outputs of those models in a way that's accessible? And it's really about those layers. A solid machine learning foundation can always produce better results than purely relying on the non-deterministic outcomes and outputs that you'd get from a lot of the other tools that I'll happily still use, but just not for guidance on machine settings.
Absolutely. Especially kind of during the run up and post that prove it session, I have certainly put more thinking into which of the different flavors of AI are or should we use and leverage on the manufacturing industrial side, and how do we find the correct ones to go kind of pull the correct lever, if you will, in order to go ahead and be successful, right? I think that there will always be the need in order for people on the LLMs, like the chatbot side, if you will, to go ahead and query and to go ahead and have that that natural language progression in conversations. I think that is one of the first major values.
Mm-hmm.
But at the end of the day, is Vlad going to go and dump a bunch of information in ChatGPT, whichever flavor, whichever model there is, and just blindly accept what it has to say? No, because it may say that Vlad is a cat today, and he can only talk to people as if he were a cat today. And that is not particularly helpful, and that is not particularly something that you're going to trust in order to go make, very large, potentially life and death style decisions.
Right. Yeah, I think it's best evidenced with if you use Cowork, right? Claude Cowork today versus what it would have done a month ago. If you present it with a set of CSVs or maybe even one giant CSV, and we start asking to do some feature engineering, some tools would just present you with a graph at the end that says, okay, these are the events that we found, these are the segments that we found. Cowork will walk you through, okay, I'm building you a Python script. I'm going to be using this, this type of technique, this type of algorithm. Do you want to adjust that? Do you want to change that? So foundationally, it's still using the technologies that make sense for data analysis. But the way it's presented, the way it's curated, that's always going to evolve and change. And that's really what the game changer looks like. But I don't think any of us are fooled, but we just got to make sure as an industry as a whole, we understand that those foundations are still core to the use cases that we're trying to solve.
Absolutely.
And speaking of which, right, going back maybe to the human factor, right, and depending, at least in my conversations, depending on whom you talk to, there is either a lot of excitement on the new tools, or there's a ton of skepticism, right, as to like how accurate and how good it's going to be. I'm curious, I guess, with the LLM wave, has the like more traditional machine learning algorithms been more accepted, more questioned, less accepted, right? Like, what has the maybe person to person sentiment been, and specifically, I would say to the industrial space?
Yeah, we kind of encounter a lot of different attitudes or a lot of different, I would say, personas in terms of how they're interacting with the twin thread technology, or as a whole, how they're investigating industrial AI and its applications. There's oftentimes there's kind of the economic buyer, somebody who's mandated at a high level. It's in our shareholder report, it's in our corporate goals for the year, we have to use AI. And I'm trying to figure out what that means. And so they're approaching it more from a, like, help us decipher what it means to use AI, because we have a lot of different, the marketing, a lot of the content out there will point them towards LLMs, will point them towards deploying their own local LLMs or deploying some version of an enterprise LLM via Fabric or some data lake. And you're like, is this actually going to help us solve use cases? And we often try to bring it back to what's happening in the four walls of your plant. What are the use cases that your process experts are struggling with? And what are the tool sets that they're currently using to solve those challenges? Can they be supplemented with twin thread? Like Maintenance is a good example of that too. Like, we're working with a customer today who's gone down the route of deploying Maintenance. They're deploying a connected worker platform. They're also deploying twin thread, and their goal is Twin thread's kind of the brain. We still want to set it off on a lot of the process-oriented use cases, the optimization-oriented use cases, and when appropriate, kick off workflows in MaintainX, kick off work orders, kick off other interactions that people can act on. But there's an entire other body of use cases that are really centered on, I have hundreds of thousands of documents, kind of what you were describing earlier, Dave. I have all these SOPs for how to run my PM, how to successfully close those out. That's not going to be something that machine learning necessarily helps you with. That's just pure context. So yeah.
Let me ask you a follow-up on that side, right? So the other sentiment that I often feel from, again, those that aren't maybe exposed as much to AI in a broader sense, is that there's always a need of human in the loop, right? And I agree with that to a certain extent, but it seems that the machine learning algorithms have always been a lot more robust than the LLMs, and that's why maybe that mistrust is sometimes misplaced. But I'm curious again, like in that essence, like have you had applications where you can, for example, feed some of those variables without having to need and double check, if the variables are accurate? And maybe to bring this to my earlier example, right? I would have loved to run R&D projects where you have a line at a certain speed. The teams are already changing the set points. We can now accurately measure the data and understand, what could be better, what could be an improvement. And maybe at that point, the machine learning algorithm could even push the envelope further, saying like, hey, we can increase by another 1%, right? And collect enough data, obviously, before there is a guardrail, and then like go further. I'm curious, maybe your thoughts on that side.
Yeah. I mean, short answer is yes. Like we have one of the published use cases that we have on our website. I think we have a co-presentation about as well. It's with Hill's Pet Nutrition. So they use Twin Thread. They've been using it now for at least 3 or 4 years, I want to say. But every single, if you guys have any pets that use Hill's Science Diet, they're using Twin Thread to make that. But they're at a point with their models where they're robust enough to take those model recommendations and automatically have those changes incorporated into live production runs. So
Really interesting.
Yeah, and what's really cool about I guess there's two sides to this. First, it's circumstantial. Like the starting point should always be human validation. You have recommendations for models. You should always go through what we refer to them as control trials. There might be other methodologies or systems that have similar phases in their project deployment where you kind of do an A/B test. Let's run a shift without recommendations. Let's run a shift with recommendations. Get feedback from your experts, understand why you didn't want to accept that recommendation, tune the model. Once you're at that point where your model is robust, has captured as many edge conditions as has been provided in the historical data, edge conditions meaning like new product introduction, new raw material supplier, maybe new equipment, like you're stabilizing the line again. Once all of that's incorporated, you can kind of be in a situation where you're running auto and then opting out. So I think you should always, and generally this is how we're deploying our tool set too, you should always have the opportunity for whoever's running that process to opt out of a recommendation, but you want to be able to relay that feedback to the model, understand why that opt-out was taken, introduce additional context for what scenario was encountered here that has never been encountered in the past that the model was unaware of. And if you can do that consistently, you can schedule retrains, you can automate retrains. You're in a really good position to minimize the amount of experience that an operator needs to have built up over years, over decades, to effectively run a line or run a process. You really shorten that curve for ramping a new resource up or a new operator up.
Thank you.
Absolutely.
That's a
Yeah.
cool use case.
No, that is an awesome use case. Shifting the concept of use cases on this theme, we always like to ask what people are doing themselves to leverage AI or to play with AI, kind of push the boundaries. You have a particularly awesome use case. Please tell the listeners what you're doing, Virag.
Yeah, I know we had a chance to chat about this a little bit earlier, but I mentioned that my father recently retired, and one of the things that I've really wanted to focus on, and actually a lot of my daily uses of AI center around how to make things more accessible for my parents, how to kind of combine as much context as I can, calendars, historical memories, so on and so forth. So what I'm calling my new project is Family Graph, and I was actually inspired by a lot of what people built at Prove It. So I'm using a knowledge graph to essentially create a family tree, but then extending it to images. So, I'm sure as Dave also mentioned, and Vlad, most of you have a lot of printed family photos, maybe even home videos, which might get an add-on here based on what Vlad's using. But I wanted to convert all of that into a repository that I can train models off of to have my parents identify individuals, events, key kind of moments that are represented in that image context that I would never have because I never lived it, and then automate the tagging of images to individuals, in addition to them being able to interact with the tool to record memories. They don't have to write everything out. They can kind of describe events, record them, it gets transcribed. So as a whole, my goal here is to just create there are tools out there, like people use ancestry.com, so on and so forth. But this is kind of like a homegrown tool for me and my family that I can deploy and have my parents involved and their generation involved in multiplying the context that they have that nobody else ever will. So they can't sift through 10,000 photos, but if they sift through maybe 200 of them, that's enough for a model to start to go through and find similarities and make that really easy. So yeah, hopefully I shared the GitHub repo with Dave and Vlad here, and hopefully once I get a couple more commits in there, it'll be production ready for other folks to try to replicate on their own.
No, I love this. I love the entire concept. If and when you're ready, we'll be more than happy to go ahead and throw the repo in the chat. It is very apropos for us in order to go ahead and do that. But no, I love the entire concept. As I was thinking specifically about the pictures, since you told me about it the first time, I will be particularly interested to know how good the model is distinguishing, especially from one generation to the next, because I imagine there'll be a lot of very, very similar looking people over the generations, right? Lots of people who look similar, lots of people with similar features. So I will be very excited to hear how it goes with the models as it trains, and maybe it'll go fantastic the first time. Maybe it takes the fourth time you run it in 3, right? I doubt it as well. But that is part of the adventure. But no, that is fantastic. Thank you so much for sharing it with us. So we do want to ask you.
Oh, sorry, go ahead.
Oh, no. We do want to ask you the final questions that we get to ask all of our guests. And as I've pre-warned you, the first one is one of my favorites, and it's also the most difficult on an industrial AI theme. It's predict the future. So where do you think industrial AI is going to go in the next 2 or 3 years?
Yeah, I think it's kind of people talk about physical AI, and that's kind of having its moment now too, because of how hardware is shrinking, and it always has, but it will continue to. But like the human AI component of it, like I think we will all basically become digital twins. From the day you step into a factory, you're going to be, you have a camera, a whole host of sensors attached to your hard hat, and your entire career is just recorded, right? It just becomes context. Like we're basically doing that today, especially for those of us who handle a lot of remote calls. We have every meeting recorded. We have note takers. We have calendars that have context for what we're doing every day. We have Google Drive tracking everything, every document you're producing. So that kind of becomes this is kind of out there, but my thesis is that kind of becomes, the individual operator digital twin when you have turnover, when you have retirements, um, that IP loss is managed by this human digital twin that's basically recorded every movement and every action and every repair, every changeover that individuals have done.
The way you describe that is very scary. I don't know.
I was going to say, I don't know if I love this or I'm terrified by it. I'm intrigued. I am certainly intrigued. If Vlad wasn't going to say anything, I was going to ask Vlad to shake his head yes or no if we think this is a good thing or a terrifying thing. It could be both.
I don't know if it's good or bad, but I think it's going to happen.
I think of myself personally, I do a lot of recording while I am at facilities already, both video and audio, for very similar reasons. But the concept of having it being a Vlad digital twin who walks into a factory at 18 and leaves the factory at 65, and every part of him is connected. And we see everything. I don't know if I love that or hate that. That might be the scariest prediction we've had. And you want to listen to some scary predictions? You guys listen to the cybersecurity predictions. Okay. That's a go live under a rock. This is like Ready Player One style life that we have got going on. And
the reason I say it too, though, like because my father basically had, like, he got asked to do the same thing as he was retiring. They're like, hey. Yeah. Can you just spend a week, recording as many audio notes as you can, as many videos as you can, walk the floor with our younger engineers. They were recording him and him explaining all these, like, that's something we think about as an afterthought. But I think the more and more that becomes the standard for how you transfer context, people are going to want to start doing that as it's happening. Maybe less scary, maybe not in a way that's like, hey, we're literally on you and recording you all the time. Maybe instead it's like, okay, when you're performing a certain activity, this gets automatically recorded. But one way or another, I think that context transfer, it's become more accepted that it involves rich media.
It's interesting. I don't know, like, where it's actually, like, again, I think it's very hard to say from a human standpoint where that's going to lead, right? Because it's possible to make the argument that on the flip side, people will be a lot more reluctant to take risk, for example, right? If you're solving a complex problem, the reality is you have certain ambiguous decisions to take. And if you take the riskier ones, perhaps it will work out better, but you're going to be always watched. So exactly. So it's, I don't know. I guess only data will tell ultimately what's going to make sense. But it is an interesting thought.
Yeah, I don't know.
One hot take.
I mean, at least I know what I'm going to wake up in a cold sweat from tomorrow night. It's certainly going to be all of the safety violations, and every time I step outside those yellow lines, does the camera like tase me in order to try to keep me to stay within those yellow safety lines? Now that is a terrifying thought. Hopefully moving to something less terrifying and futuristic, some career advice. So if someone is early to middle career, maybe looking to get into the industrial, maybe in the industrial looking to get deeper into the AI space, what is the best career advice you have for them?
Yeah, I think, software development has always relied on front end, back end, and then full stack occasionally, right? And I think we have to get into a similar mindset when it comes to how we're incorporating new technology. We have to be like full stack operators. So if you are in industry today, if you're a process engineer and you are interested in using technologies and using industrial AI and different use cases that you have, that's a great opportunity for expanding the skill set that you're competent in. But it's I don't know, maybe it's a bad thing that like you don't need as much depth in a particular skill set that a lot of these tools will help you make up for. But if you are a full stack operator, if you have enough context across a lot of different topics, you're better suited today than you ever have historically to be able to do all of those things. Like even when I was starting off in my career, it was okay, you do the training. Now, are you going to be a Delta V engineer? Or are you going to be a Syncade engineer? Are you going to be
Mhm.
recipe authoring? Or are you going to be building DCS? And it's like
Yep.
that bridge compartmentalize everyone and their skill sets. I think
Mhm.
we're so far away from that now, so you kind of have to embrace it.
Yeah. No, I agree. I think that knowledge or theoretical knowledge has never been easier to go ahead and prompt. And I do think that people who have those base skills will provide more opportunity. And I think going from like one group, like if are you a DCS engineer, are you a recipe
Yeah.
engineer, or cross platform? I do imagine that will become easier and easier with these skills and with these different tools. So I like that. You said you've got some content recommendations for us. What do you have for us today?
Yeah, I think, or what I was referring to earlier too, it's the folks that help inspire me to build things like Family
Mhm.
Graph, or to go
Yeah.
and take on technologies that I've never used before professionally, and just see what I can piece together. So
Hmm.
um, one of them is one of the early Tesla engineers, Andre Karpathy, or I don't know if he's saying the last name right. You guys might know better, but I feel like the way he breaks down a lot of, he has some very long form videos, so it's not necessarily
Hmm.
as catchy or like fun to watch as some of the other engineering builders who are physically building things. He does a lot of
Hmm.
concept explanation and then like applicability. I think he has a recent one I need to watch on the Mac Mini OpenClaw setup that I know you guys were referring to that you guys are using. So um, yeah, I tend to. I should probably also read more, but the videos help me kind of like pause, see what if I can replicate what they're doing on my screen, and
Yeah.
kind of go back and forth. So he's a really good explainer in that sense.
Absolutely. No, that is fantastic. Thank you. I feel like the Mac Mini OpenClaw is as much of an internal meme on at least my LinkedIn feed than it is an actual reality on my LinkedIn feed. There are people doing it.
Yeah,
Um,
yeah,
I feel like it's just more of a meme on the industrial side than anything else. It's a
yeah.
lot of work to go stand up your own open source software, and the additional tangible value that one gets out of it, as opposed to going and standing up a different Docker container, is potentially questionable based upon the comments that I've seen people have. Virag, that's amazing. So, question for you: some sort of interesting idea or innovation. What do you think is ripe in the industry to go ahead? And what do you think is ripe in the industry to go ahead, an idea, something down those lines?
We talk about digital twins at different levels in the twin
Mhm.
thread platform, and for a plant or a site, that often means that there's some data streams associated with utility costs or consumption or high
Mhm.
level, not necessarily process data, but just data streams that bubble up and end up falling into the context of what the plant is doing. Um,
Mhm.
One thing that I've heard, and it's actually I'm stealing from some of the customers that we work with, and like some of the process we've been talking to, people building up this concept of like sovereign intelligence on a site by site basis. So
Yeah.
it kind of goes hand in hand with the proliferation of physical AI, being able to deploy models that they're still physically residing at sites, and they're bridging this gap between um, the data that's being collected from a process, but then also the people. So sovereign intelligence related to who are the people that I have at this organization? How do they all map to each other? Who can I rely on? What different workflows? So a little bit different from like the instrumentation telemetry centric digital twin that we talk about in the twin thread world. But I imagine every organization has their own version of organizational matrix, historical background, suppliers that they
Mhm.
use, like all of this tribal knowledge that you can
Yeah.
turn into sovereign intelligence. That could be pretty cool.
Interesting. I I like that. That's another slightly less terrifying thing to spend some time pondering. So I appreciate that, Virag. Last question for you. This has been awesome. How can our listeners help? Who should reach out? Who are you looking to connect with? Kind of your open forum to ask our listeners anything.
Yeah, I mean, you guys offer a great platform here, and obviously a lot of incredible speakers and companies have been represented on this podcast before as well. So I would say call to action is just examine where you are. And where you are can mean anything from, do I have data? Am I using data? Am I using data effectively? Am I using that data for specific use cases? And wherever you sit on that spectrum, you have next steps that you should be going into. You can start identifying what the gaps are, use one of these LLMs to help kind of do a self audit of your systems, and if they're robust enough to start trying to train models off of. If you're further on that maturity curve and you want to deploy industrial AI in a way that gives you recommendations, that helps you go closed loop, that helps you give operational insights, call us up at TwinThread, shoot us a note. We're definitely interested in helping people get out of that pilot purgatory and get into a situation where it's not just retroactive, but that real-time analysis. But yeah,
Awesome.
That's about it. Appreciate the talk here today.
Absolutely.
Let me ask you. I was going to ask one last question. So I have not personally deployed TwinThread. If someone were to try, and I guess wanting to try something on their own, is that possible? Is there some kind of a trial? Do they only get to walk through with you? What does that look like?
Yeah, so we have what we call a learn subscription, which is basically, we pump simulation data into an environment that you can use for 30 days and access our training to kind of walk through side by side. What does it look like to build a twin? How do you build a model? It kind of is a homework oriented training. And then when it comes to deploying it for your specific use case, we have different subscription models. Some of them that are, if you want to scale this use case out at larger scale, at the beginning, there's already discounts built into the pricing. Otherwise, it's basically like a pay as you go. So for all the data, you pay for however much data you're consuming, and that's, there's like a metering mechanism in the platform where you can see how many items am I using for this model, for this model, for this model. So if you wanted to try something out at a smaller scale, you don't necessarily have hundreds of data points. You have maybe a couple dozen, and you want to just use a small month-to-month subscription. You can do that with TwinThread as well.
Awesome. Thank you.
Yeah, no, thank you so much for that, Virag, and thank you for joining us. Thank you, everyone, for joining us. If you guys have made it this far, thank you so much for joining it. We hope you enjoyed the industrial AI theme. If you haven't listened to the previous 4 episodes, please go ahead. It starts with Vlad and I back on episode 252. We're talking about kind of state of industrial AI. We're talking about things that we're doing, things that we're seeing, and then it goes and continues from there. All of them absolutely fantastic conversations that you should go ahead and check out. We do want to thank MaintainX for sponsoring this theme, the continued support of the show. Let's see, beyond that, in the links below in the show notes, go check out the Deterministic AI webinar with Virag. We've got TwinThread, we've got LSI, we've got 4IR, we've got Logan and Straw on there as well. It should be an awesome conversation. I'm excited to go sit back and listen to some other folks who get to go talk about this stuff live on the internet. If you guys have made it this far on YouTube or podcast format, you are absolutely fantastic. Please do the like and subscribe and rate us 5 stars and follow along and all of those amazing things. We'll continue to get podcasts in your earbuds Thursday morning. As one side note, Vlad and I are off the next couple of weeks of live shows. You guys will probably have some replays